This video is about the motion concept known as acceleration. Have you ever been on an airplane? When it's getting ready to take off, it might be sitting still, and then when the tower gives clearance and they start to take off, the airplane starts to go really fast and you feel yourself get pushed back in the seat. Well, going faster and faster is something that you might recognize as acceleration. But as we are going to see, this is not the only way an object can accelerate. As a reminder, we've been talking about motion, and we've looked at the concepts of speed and velocity. Speed is when an object moves a certain distance in a certain time. The formula is very simple. Speed equals distance divided by time. And velocity is very similar. The difference is that velocity has to have a direction. And so instead of distance divided by time, we say that velocity is displacement divided by time. Displacement is a vector quantity that includes the direction of motion. So you can speed by going any given amount of, say, meters per second. But when you measure velocity, you have to add in what direction you are going as well as the meters per second. You can measure speed over a period of time, and we would call that average speed or average velocity, or you can measure it in a given moment in time, in which case we would call it instantaneous speed or instantaneous velocity. The speed or velocity can change over time though, so your instantaneous velocity could go up or go down. Well, that's one way to define acceleration. Acceleration is any change in speed or velocity. But an even better way to define acceleration is it occurs whenever there is any change in a state of motion. If you think about velocity, it involves direction. So if you speed up in a given direction, that is acceleration. If you slow down in that given direction, that is a change in velocity, and therefore that is also an acceleration. And if you just change direction without changing speed, that is also an acceleration. If you think about being in a car, for example, when you speed up, if you went really fast from, say, a red light, you could feel yourself getting pushed backwards into the seat a little bit. If you slow down really fast, you can feel your body moving forward. Well, if you go around a really sharp curve, you can also feel your body moving. That is a form of acceleration. It shows whenever there is a change in motion of the car, your body also undergoes a change in motion, and you can feel it. We'll talk more about that when we get to the concept of force. So, to be clear, acceleration applies to decreases as well as increases in speed. We use the same term in physics. Whenever you put the brakes on a car and you slow down, in everyday language, you might call that deceleration. And we would use that term in physics as well. But technically, what that should be called is negative acceleration. And we refer to it as negative acceleration because when you do the calculations, you will come up with a negative magnitude, a negative value for your calculated result. So slowing down is negative acceleration. But keep in mind that acceleration also applies to changes in direction. So you do not have to speed up or slow down. You change your velocity by changing your direction. So if you're driving around a curve or going up or down a hill, that is a form of acceleration. Acceleration then is a vector quantity. It depends on direction. So the best way to define acceleration is the rate of change in velocity, not the rate of change in speed alone. Speed does not involve the direction. So any change in speed is always a change in velocity and therefore an acceleration. But velocity can also change if the object is not moving in a straight line. If it's not moving in a straight line, it is accelerating. To keep things simple for now, we will only consider acceleration when the object is moving in a straight line. If velocity is measured in distance per time units, like meters per second or miles per hour, but acceleration is the rate of change in velocity per time, that means there's a second time unit involved in the calculated value for acceleration. So accelerated units are distance per time per time. This gives students a lot of trouble sometimes conceptually. For example, calculate the acceleration of a car if it changes speed from 0 kilometers per hour to 10 kilometers per hour in 1 second. Well, we said that acceleration is the rate of change in velocity over time. In this case, since it's moving in a straight line, we can just calculate that as a change in speed over time. That would be 10 kilometers per hour in 1 second. Our answer would be 10 kilometers per hour per second. That's a very unusual unit of measurement. Another way to read that is 10 kilometers per hour second. You'll note that there is a unit for time twice. In this case, the hour is 1 unit and the second is a different unit. They don't have to be different units, but they do have to be both time units in the denominator. So just to summarize, acceleration can be any change in velocity. So if a car is speeding up, for example, that is a form of acceleration. We would call that positive acceleration, or calculate it as a positive magnitude. If a car is slowing down, that is also an acceleration. It's a negative acceleration because if you calculate its value, you will come up with a negative number for the size or magnitude. But it can also be a change in direction. So if the car is not moving in a straight line, it is accelerating even if it's going at a constant speed. And of course, you can change both speed and direction at the same time and accelerate in 2 different ways. But as I said, for now, we are going to just consider things to be moving in a straight line. We'll have to get to directional changes in a later chapter. So to put the formula into a magic equation triangle, acceleration is a change in speed, since we aren't going to change direction. We'll use speed in the numerator, over a change in time. If we draw a magic equation triangle, the speed is at the top of our fraction, so it'll go in the top of the triangle. Time, we don't have to show the delta in front of time because time is always a change, so I'll just put a t there. And acceleration will go in the empty box. So we can use this equation to solve for any one of the variables when given the other 2. In the next video, I want you to watch the next video after doing the 4 review problems in the online text. So read the homework section for the next, before you do the next video, do those 4 review problems, which I actually assigned in the last class, so I hope you've done them already. Then watch the video. It goes over those 4 problems and some additional problems using this formula and some other derived formulas. So go ahead and do the review problems and then watch the next video.